Yeah, 22.7 is for something else. 22.7, there's one more, but it's close to 22.7. It's not quite 22.7. It's 24.7. 24.7 is the molar volume at 298 Kelvin, and then rather than 1 atmosphere, it's 1 bar. And so that's pretty much it. All right, the average molar mass of dry air is 28.96 grams per mole. Calculate its density at 298 Kelvin and 1.00 bar. You guys know the density equation? Do you know the molar volume equation? What's the molar volume? Do you have it memorized, or can you derive it? Derive it. What's the molar volume equation? Number 2. RT over P. And so select the correct equation for molar volume. That's number 4, would be E, RT over P. You can derive that or memorize it. What's the density equation? Do you have that one memorized or derive it? Can you derive it? Yeah. You can always check if your derivation is correct. The density is going to equal, well, density is just going to equal mass over volume. And then we know volume is equal to nRT over P. We'll substitute that in here. So it's mass over nRT over P. Well, mass over N is called the molar mass. So this is molar mass and then invert multiply times P divided by RT. We can see if we got the equation right if the units work out. This is why it's important to make sure the units work out. So molar mass is in grams per mole. That's 28.96 grams per mole. P is in pressure is in 1.00 bar. R is 0.08206 liters times atmosphere per mole Kelvin. And then the temperature is 298 Kelvin. And so let's see what cancels. Moles cancel, Kelvin cancels, atmospheres and bars don't cancel, so I have to convert. The conversion factor you don't have to have memorized. That would be a given. And the conversion factor is this. It's 1 atmosphere is equivalent to 1.01325 bar. It takes more than 1 bar to make an atmosphere, so bars are a little bit smaller pressure. So let's put that in here. I'm going to change bar into atmospheres. The bar cancels, atmospheres cancel, and that leaves me with grams per liter. So this is the right equation. If I didn't get the right units, then it's the wrong equation. So what does it come out to? Let's check it. 28.96 divided by 101.325. Divided by 0.08206. Divided by 298. 1.168. 1.168 grams per liter of the density. So it looks like it's D, 1.17. How many liters of O2 gas are required to combust 1.2 liters of propane? This one should require no calculator. Uh-huh. 6 liters is correct. Yeah. We use Avogadro's law. Avogadro's law says the volume and moles are proportional to each other. So if we have a mole ratio, 1 mole, 5 moles, 3 moles, 4 moles, it's the same as a volume ratio. The volume ratio could be 1 liter, 5 liters, 3 liters, 4 liters. Avogadro's law works for gases, so as long as they're gases, we're okay. But, well, propane's a gas, oxygen's a gas, CO2 is a gas. However, water, is that a gas or? No, it's a liquid, so it doesn't work. We're dealing with liquids. Yeah. Avogadro's law just holds for gases. And so the moles hold for whatever. It doesn't matter if it's gas, liquid, or solid, or AQ. It's going to hold. So the mole ratio is always correct. 1, 5, 3, 4. But the volume ratio isn't. Okay, it's always correct. So 6 liters is correct. We need 5 times more gas. So if I had 1 liter of propane, I'd need 5 liters of oxygen. If I have 1 gallon of propane gas, I'd need 5 gallons of oxygen gas. So 6 liters. At 1 atmosphere and 290 Kelvin, how many liters of water are produced when 24.45 liters of propane is combusted? 24.45, around there, is kind of a special number. It's like 24.5 liters. 24.5 liters of propane, that's a number that should trigger some kind of association. And what is an association? 24.5 liters is equivalent to what? 1 mole. 1 mole under these conditions here. At 290 Kelvin in 1 atmosphere, this is 1 mole of gas. And so, how many liters of water are produced when 1 mole of propane is combusted? If 1 mole of propane is combusted, how many moles of water are produced? If 1 mole of propane combusts, how many moles of water are produced? 4. How many liters is 4 moles of water? All right, so why don't you do that calculation and then